Okay, we're in week 10. So we covered the material here in week 10 on exponential and logarithmic equations. We talked about the difference between exact and approximate. Hopefully that's been clear. Again, when I say hope, we hope that you've gone over the material, that you've made sense out of what was presented to you, including the examples that we did together. All right. Now I say do together. Certainly it's me talking through those examples. I'm hoping it illustrates the points that I've made during lecture time about what's expected from you. So we went through a bunch of examples. And at this point, we're hoping that you've also took the time and the effort to study that material and then reinforce it by doing the supplemental problem set. And by doing the supplemental problem set, you should feel comfortable with the material at this point. All right, I'm going to go to the problem set though, and I'll do the problems individually as if you're at the whiteboard doing it, and I'll try to talk about that in stages with you. All right, so let me just go to a new share. And I'll talk to the problems, including the use of technology in the problems. So let me start with number one. Number one is, solve for X. And it says both use an approximate and an exact answer. Of course, my goal is to get exact answers. And then I'll talk about, let's take a look at that here. And let me write this one down for you. So if I were looking at this and just, ballpark it, I would say X, if X were 2, let me write this down for you. 2 to the 2 would be 4, so definitely not 5. And if I said 2 cubed, I would say 2 cubed is 8. And I know that 5 is somewhere between that, all right, between 4 and 8. So I'm going to say the answer is, I'm going to say closer to 2 than it is to 3. So it's closer to 2 than it is to 3. Now, someone says, could you play this game all day long? You could, but I just want to solve the problem. And I'll go through how you would do that. 2 to the X equals 5. What I would do is I would take log of both sides. So natural log, 2 to the X, would be the same thing as the natural log of 5. Now, what am I saying? Those numbers represent the same thing. Okay, now what do? I'm going to use those, the rules that I know about log. So that's going to be ln x ln 2 equals ln 5. And now I know what X is. I divide both sides by the variable's numerical coefficient, which is ln 2. So I know X, write this down for you, is the natural log of 5 over the natural log of 2. If you approximate this on a computer, what are you going to get? 2.3219 to the nearest, fourth decimal place. All right, that answer is right over here. All right, let's go to number 2. Again, these should be relatively simple questions. That's if you studied the material, they're simple. If you haven't studied, nothing's simple. So let's do number 2. And what I'm going to do for number 2 is, solve for X. And to do that, again, you might say to yourself, I just want to, plug numbers in. You could. It's pretty easy to, by inspection to realize just looking at that 3 plus some number, that's kind of complicated, equals 5. What does that number have to be? 2. So looking at that, you could probably simply say, well, log base 10 of what number would give me 1, because if it was 1, 2 times 1 is 2. You would just say 10. The answer is 10. But I want to go through the method, right? Because it may not be so easy. Let's write this down. 3 plus 2 log base 10 of some numbers equal to 5. I would subtract 3 from both sides. Relatively simple to do. And what do you get? 2 log base 10x is equal to 2. I would divide both sides by 2. Relatively simple to do. And the reason I'm doing is I'm trying to isolate the log. And now what do? I rewrite the log as an exponential. And so what would you get over here? You would get x equals 10 to the first power, which means x is equal to 10, right? Same answer we're getting over here. All right, let's go to number 3. Again, relatively simple questions. This should be rather straightforward. Just give me a second here to get everything out of the way. Okay, so one thing I want to do is I want to try to get, just one log out of this. So I'll just keep rewriting it. And it's going to be log base 3 of a product. And that product's going to be x times x minus 8. And that equals 2. All right, I'm ready to rewrite it. So it's not a log. What do I get? Well, I would get x minus 8 equals 3 squared. All right, now I get x squared minus 8x is equal to 9. X squared minus 8x minus 9 equals 0. A relative, like, I'd say an 092 level quadratic to solve. That's going to be 9 and 1. And let's see, minus 9 plus 1. X could equal minus 1, or x could equal 9. Now, the problem with this, just like we did Math 100, some of these answers may not work. They may be strange about the manipulations I've just done. So I want to check them. And where do you check it? You must check it in the original. So let's check 9 first. Let's see if 9 works. What do you get? Log, again, I'm checking. And I'm checking x equals 9. What do you get? Log base 3 of 9 plus log base 3 of 1 is equal to 2. All right, so I'm going to look at them one at a time. And, log base 3 of 9, well, 3 raised to the 2 would give you 9, so that works good. And plus 3 raised to what power would give you 1 would be 0. And that, of course, is true. So this works beautifully. All right, let's try minus 1. I immediately see a problem. So if you check minus 1, what do I see? Log base 3 of minus 1. Well, there's no such number. A real number is going to give that to me. So I'm going to cross that out. All right. So there's only one answer, x equals 9. What does it say in the answer key? X equals minus 1 doesn't work. It's extraneous. All right. Let's go to the next question, which would be question number 4. As I go through these should be relatively straightforward questions if you studied the material that we presented to you. So let me put this down for you, and I'm going to go through with you. All right. Now, so if I'm doing this problem over here, I'm wondering, could I figure this thing out without too much work? And I think I can, because 4 and 16 have a similar base. And the base they have in common is going to be base 4, right? So let me go to that and write down a base 4. It's going to be 4, 3x minus 5, and 16 base 4 would be 4 squared. All right. So what does it tell me? It tells me 4 raised to a power is 4 raised, well, those powers must be the same. So let's write that down. 3x minus 5 is equal to 2. Add 5 to both sides. You would get 7, and then divide both sides by 3, and you would get 7/3. So I'm going to say x equals 7/3. I want to point out, I do want to check it. And what would you get over there? Well, it would be 4. And again, I'm checking it. If it's 7/3, 3 times 7/3 is going to be 7 minus 5. And what's 7 minus 5? It's going to be 2, right? So what's 4 squared? It's 16. It checks out beautifully. All right. All right, let's go to the next question. Next question is number 5. And this one just simply says solve it. That's all it says. How would I do that? Well, I got to recognize that the natural log, right, is log base e. I'll write that down for you. So log base e of x equals minus 2. I'm going to write as an exponential. When I get x equals e to the minus 2, it's now solved. If you want, you can check this. Natural log e to the minus 2 is going to be minus 2 natural log of e. Natural log of e is going to be 1, so it's going to be minus 2. And it does check out beautifully. All right, let's go to number 5. I'm sorry, number 6. And this is number 6 over here. All right, let's go through it in stages. All right, so I'm getting, a log equation, logs equal logs. So I'm going to write it as one log equals another log. And let's write that down. So what are you going to get? And ln, that would be x plus 1 times x minus 2 is equal to the natural log of x. So what do I now know? I know that these arguments must be the same. All right, let's take a look at that. And that means x plus 1 times x minus 2 must equal x. Well, let's keep working through it. What do you get? X squared. Let's see, minus 2x plus x is minus x. Minus 2 equals x. It's quadratic, clearly. X squared minus 2x minus 2 equals 0. Well, I got some troubles here. I'll tell you what my troubles. I can't factor it using my fingers, so I need to use quadratic formula. And it's going to be x equals, let's see, twice a on bottom, which would be 2. Let's see, minus a minus 2 is 2, plus or minus the root. B squared would be 4, minus 4ac. Let's see what's that going to give me. 4 times 1, that's 4, times a minus 2 is minus 8 plus 8. Let's keep going. These are complicated numbers. I realize that. 4 plus 8 is 12. I realize I got a square there. So x equals 2 plus or minus, well, the square root of 4 is going to be 2, and that'll be root 3 divided by 2. When do we get over here? X equals 1 plus or minus root 3. I have two answers to bother with, right? So what are the two answers going to be? X equals 1 plus root 3, and the other one is going to be x equals 1 minus root 3. All right, I want to emphasize that when you're doing these problems over here, it's important that you really don't need a calculator to do this problem, but it would be nice to understand that you have to check these to see if they're the right answer or not. And I'm going to say over here is, looking at this one, again, I'm looking at them separately. I'm looking at this one over here, and I want to check it. Right, so it's too much work to check. Well, let's just write it down. What's going to be ln? Let's plug it in. What do you get? 1 plus root 3 plus 1, which would be 2 plus root 3. Plus ln. Well, let's see. 1 plus root 3 minus 2 would be root 3 minus 1. And is this equal to the natural log of 1 plus root 3? Well, before I do anything, I want to point out to you, the logs can be done because each, the log of the first sum 2 plus root 3 is a positive number. I can do that log. Root 3 minus 1 is still a positive number. So if it can do it. Let's put this down over here. ln multiplication. So it's going to be, let's see, 2 root 3 minus 2 plus 3 minus root 3. I want to see if this checks out, by the way. And what do you get over there? Well, let's see. That would be 1 plus root 3. Yep, it works. This is good news. This is a good answer. All right, let's check the other one. And let me see if I can check the other one. I'll do it on the side over here. I'll do it in blue. All right, so what do you get over here? ln 1 minus root 3 plus 1 would be 2 minus root 3. That can be done. Plus ln, what do you get there? You get 1 minus root 3 minus 2, which would be, let's see, minus 1 minus root 3. This is bad news. It's a negative argument. So this can't be right. There's only one possible answer there. What's that answer going to be? 1 plus root 3, which is clearly indicated here. The other one is extraneous. All right, so I think that pretty much covers out. Let me I gotta be careful about what I'm saying over here. We just did number 6. We're going to go to problem number 7 now. All right, let's take a look at it. Don't be discouraged. We do not write problems that are not illustrating what we teach in class. I really mean that. They're going to illustrate what we're teaching in class. Let's see if we can do that. All right, I'm going to see if I get the same base. I'm going to say base 3 on both sides. And let me see if I can write that down. It's going to be 3 to the x squared plus 4x equals 3 to the minus 3. Now, what do I know? Same base, they're raised to powers. These powers must be identical. So I'll write that down for you. X squared plus 4x equals minus 3. All right, let's see if we can solve that. I'm going to add 3 to both sides, clearly quadratic, and factor it. I'm using the zero product rule, by the way. So I'm going to say x equals minus 1, or x equals minus 3. I'm going to check it. And what do you check it back in the original? Let's do minus 1 first. I'm checking. And what would you get? 3. Well, if I plug in minus 1, I get 1 minus 4, which is minus 3. And that does equal 127. That does work out beautifully. Let's try the next one. I'm going to check. X equals minus 3. More complicated. What do you get? 3. That would be minus 9. I'm sorry, 9, because minus 3 squared is 9, minus 12. And that's still minus 3. It also checks. So I got 2 good answers. All right, I'll put a box on it. These are good answers. As, by the way, is indicated in the answer key. All right, let's go to the next question, which is going to be number 8. Number 8 says, oh, it's tricky. I don't think it is tricky. But the reason I say it's tricky, not a lot, but some instructors came to me and say, oh, this is a tough problem. I don't think my students can do that. And I'm going to say, I think you can. All right. Whoops. So what happened there? Let me do that. Okay. And I'm going to write down, I'm looking at it. I'm going to see if I can solve it. And I'm going to multiply both sides by the LCD, or what some people call cross multiplication. Nothing wrong with that, by the way. So let me see if I can do that. That would give me, let's see, 3 times 5 to the x minus 3 times 5 to the minus x equals 2 times 5 to the x plus 2 times 5 to the minus x. I'll be very careful here. I'm going to add 3 times 5 to the minus x to both sides. Whoops, I'm sorry, minus x. And I am going to subtract 2 times 5 to the x from both sides. All right, what do you get? You're going to get 5 to the x on the left. And on the right side, you're going to get 5 times 5 to the minus x on the right. So you can keep rewriting it. We'll get the same base on both sides. Look like 5s are commonalities over here. So it's going to be 5 to the 1 minus x. All right, I'm there. Why am I saying that? These exponents must be equal. Let's write this down. X equals 1 minus x. I'm going to add x to both sides. You would get 2x equals 1, and then divide both sides by 2, and you get 1/2. If you want, you can check that. Someone says, how do you check that? You'd plug it in, and I want to point out what that plugs in. It looks like, it would look like root 5 minus 1 over root 5. This is the check, if you want to check it. Don't feel obligated to do so. The bottom would be root 5 plus 1 over root 5. Multiply top and bottom by root 5. And what do you get? You would get 5 minus 1 on top. And on bottom, you'd get 5 plus 1. What does that give you? 4/6, which is going to be 2/3, which is exactly what they said it should be. All right, it does work out nicely. And again, I really don't think that's tricky. Again, some people may disagree with that. All right, that was number 8. And I'm going to do number 9 now. And let's take a look. Whoops, sorry about that. And let's do number 9. I'll pull it off to the side. Let's get rid of this stuff over here. A lot of stuff to get rid of, huh? Okay. I guess it says it's tricky. I really don't believe it's tricky, but that's depending on your take on the matter. I'm going to just go through it. I'm looking at it, and I'm going to, certainly you could rewrite the problem. I guess that's probably the most important thing to do right now. Let's put this down. So e to the x minus 6 over e to the x is equal to 1. Now what I'm going to do is get rid of the fraction now. I'm going to multiply both sides by the LCD, which is e to the x. What are you going to get? E to the 2x minus 6 equals e to the x. And I'm going to keep rewriting it. E to the 2x minus e to the x minus 6 is equal to 0. Well, I'm going to say this is quadratic. E to the x, e to the x, and then I'm going to say 2 and 3. Factor beautifully. Okay, zero product rule. I want to point out that means e to the x is equal to 3, or x would be equal to the natural log of 3. This would be e to the x equals minus 2. Well, that's not possible. For a real number, e to a power is never going to be equal to minus 2. So this one doesn't work out. So I'm going to say this is my answer. And if you want, you can check it. Let's go through the check. How do you get a check? Plug it in. What do you get? E to the ln 3 minus 6e to the minus ln 3. I know it's tough. What do you get for the first one? It would be 3 minus, well, this one more difficult. It's actually going to be 1/3. So it's going to be 6 times 1/3. Well, does that equal 1? I might put a question here. Maybe it doesn't. What do you get? 3 minus 2. Certainly that equals 1. It checks out beautifully. That's the exact answer. If you want the approximate answer, use a calculator. So you're going to need a calculator for this one. Need a calculator. All right, you're not going to be able to do that in your head. All right, that was number 9. And now let's go to number 10, which is going to be on the next page. Oh, it was. Where is number 10? Oh, there it is. Sorry about that. I guess I inserted a page there. Oh, by the way, that's the picture. Okay, so here's reading through. It says, find the time t required for $1,050 investment to double to become $2,100. So they want the investment to double, and the interest rate they're giving you is 5% compounded continuously. So I'm going to write the formula down for you, and the formula here is going to be, A. Let me put it in black for you. A P E to the R T. Okay. What's P? I'll write this down for you. The P is 1050. The A is going to be 2100. That's a doubling. Right? The R is going to be 5%, which is 0.05. Let's write that down. 2100 equals E. I'm just simply copying this over here. What's R? 0.05 T. I got to solve for T now, right? Divide both sides by 1050. Relatively simple. Don't need to calculate for that. That would be 2. E, 0.05 T. I'm going to rewrite this as a log, or take log of both sides. What do you get? ln 2 equals 0.05 T. And now what I'm going to do, I'm going to divide both sides by 0.05. So I know what T is. What's T? It's the natural log of 2 divided by 0.05. Here comes the tricky part. So I don't know what that number. I would hate to tell someone that's what the number is. You need to use a calculator for that. If you did a calculator, the natural log of 2 divided by 0.05 would be roughly 13.86. So for the money to double at this rate, it would take roughly 14 years. All right. Okay, so I'm going to briefly go back over to Sage. Give me 1 second. And let's take a look. We got related Sage code over here, right? Let's take a look at that. And again, we're trying to learn. That's the whole point of doing this. So let me clear. I'm going to reset. I'm just typing in the same commands. Again, for students who are using CoCalc, same commands. You're just not hitting return. You're hitting shift return. All right, x equals a variable. And we'll talk about this looking back over the notes in a second. Got that covered. Solve. You know, I'm getting tired of typing. I'm just going to copy paste now. I want to point out this is a very, very familiar question over here. All right. And I'm going to do this one too. Copy paste. We'll tell you where these are coming from in a second. Okay, let's go back over it. And someone says, why do you need to go back over this? It's important that you start thinking about, looking at the code and then going back over and how does it relate to these things over here? So the first thing I want to see, do I see anything that looks like this equation over here, which is e to the x minus 6, e to the minus x? And that's this equation. Let me just go back over this equation right over here. Let me go back to my terminal and let's talk about what the answers they've given me. And the first answer they give me is they've given me this log3. Let me repeat this. In most upper level mathematics courses, the log stands for natural log. All right. Now, granted, on your calculators that you use, log is base 10. But almost all advanced algebra systems, they really do just use the log for base e log or the natural log. So they say, log base e of the number 3. Well, that's the answer that we've given you. Here's something strange to you. You might look and say, what is this guy over here? There's actually a complex solution to the problem. I would not worry about that because we're only doing real number arithmetic in this problem set. What's the next one? Where's that coming from? I think that for number 8, if you look at number 8, and again, I want to point out number 8 is also given to you in the Sage code. And this is number 8 over here. And let's go back over that. I'm going to pull this up for you. And it gives me something, again, for some students say, oh, you only gave me the answer 1/2. It's also giving another complex solution to the problem. And this is the complex solution over here. All right. Let me just type that in for you and hit enter it. You notice it doesn't do anything. All right. I'm going to do something that might seem strange to you. I'm going to put a decimal in it and I'm going to force it. And what does it give me? It gives me something over here. But again, it still doesn't want to evaluate the log of minus the square root of 5. So let me put this down for you. I'm going to type out everything here, log, and that's going to be minus the square root of 5.0. You get the idea what I'm doing over there? Divided by the log of 5.0. All right, what does it give me? Exactly what I'm expecting, a complex number. I'm getting the complex number now. All right, we're only doing real number solutions to these problem sets over here, though. All right, that's about it. Thank you.